Ladies and gentlemen, welcome back to this tutorial. If you remember, in the previous tutorial we actually worked on our camera controller, where we could actually rotate the camera, and when we move we also rotate the camera with the character. Alright, so uh, in this video we're actually going to finish the camera setup. There's some few things we have to touch on before we clear everything related to the camera. Alright, now I'm going to enter into play mode, and I'm going to show you one particular problem we have right now. Alright, so now let me get close to this obstacle here. If you see, when I rotate the camera is like passing through the obstacle. You see, the camera passes through the obstacle in front here. So like, we have to create a script where the camera won't pass through this obstacle. Like, there will be collision between the camera and the wall. Alright, so if we have walls in our game, like maybe we have like a door or something, we don't want the character to see what's hidden behind the door. It wouldn't be possible, because when we rotate the camera, it's actually passing through the object and we can see the opposite side. Alright, and we don't want that to happen. Okay, so we're going to finish on the camera controller script. We are going to write a code to actually handle that collision for us. Alright, so let me hop out of play mode. I'm going to open my camera controller script so we can fix that error. Alright, so we don't want the camera to actually be passing through objects. So now we're going to use the physics line cast in this one. Alright, we're going to use physics line cast, the Unity physics line cast. Okay, so we are in a camera script. We actually wrote this script in the previous tutorial. We had all these things done. Now what we actually going to do now is we are going to actually create another object here. So in our camera settings, we actually going to have like a header, okay, to kind of describe what this variable is actually going to do, what's going to store. So we're going to have a nice header in the Unity inspector. Alright, so what we're going to do here is we actually want to say this is going to handle camera collision. So we say camera collision. Okay, with this one done, the next thing we're going to do is to create a public variable, and it's going to be a transform, and this is going to be cam position. Alright, this is actually going to be the camera position. The next thing we're going to do also is we're actually going to create a vector3 variable here, and this vector3 variable is going to store the initial cam position, so initial cam pose. Alright, so we're going to actually have the initial cam pose. So I didn't spell initial well, so it has to be L, initial. Yeah, so it's going to store the initial cam pose. Now what I'm going to do is, in my start function, I'm going to do camera settings dot initial cam pose. So what's the name of the variable again? So it was a vector3. I think there's a problem somewhere. Yeah, initial cam pose. So why am I getting an error? So I say camera settings. It seems not to be working. Camera settings dot initial. Wow, this is weird. Alright, you know what we're going to do? Actually, let me just create the variable outside of this function. Okay, so I'm going to cut this guy from here. I don't know why I'm not able to actually access the variable. I think maybe this class hasn't been instantiated in the once the start is called. I don't know what the problem might be, but let's create the variable here, initial cam pose. In our start function, we're going to say initial cam pose is equal to main cam, the main camera dot transform. We're going to access the transform of the main camera, and we are going to say the local position of the camera. All right. So we are going to access the local position of our camera and store in the initial compose variable. All right. Once we have that done, the next thing is we actually going to do the wall collision setup for the camera. All right. So in the wall collision setup, this is what we're going to do. We're going to say void handle cam, and let me just do cam collision. All right. So this is going to handle the camera collision. And one last thing, we're going to actually create a raycast variable over here. We're going to say a raycast hit variable, and it's going to be our hit. Okay, so any object we hit is going to be stored in this raycast hit variable. So the first thing now we are going to do is to write our raycast function. The raycast function is going to be this way. So now remember, we are executing the camera script as a script that's supposed to execute once, even when we are in edit mode. So when I say edit mode, it means when we are in the Unity editor, exactly in this editor view, in the scene view, the script will be executing over and over again. So if you look carefully, when I select my player and drag the player, the camera follows the player. Even when I'm not playing the game, the camera is still following the player, because this script is executing in what? Edit mode, right? So if you look at our script, we actually following the player with late update. Okay, and since the script is executing in edit mode, it's actually following the player. Okay, but over here we are actually using a conditional check here. We are saying if the application is not playing, we want to return out of the update function. So we don't even do any of this. Okay, we don't do any of this function calls. All right, so now what we actually have to do is find a way to handle our camera collision. Okay, so we also have to be able to know that, okay, we don't want to like be colliding, we don't want to be running the handle camera collision script, okay, once we are in edit mode. Okay, but I think the update function handles that for us. So first thing first is I'm going to write if my physics dot line dot line cast. Okay, so now if physics dot line cast, now the first thing we want is our player is the target. Okay, so now if we draw a ray from our player, target the transform the position, all right, plus, okay, our player transform dot up. Okay, so we remove some units up. Okay, so you are drawing a ray from our player. So now what's actually going to happen when I switch back to the Unity editor, target dot transform dot position is actually here. So this is the player's position. It's on the base of our level here, like on the base of the player's foot. All right, so when we do target dot transform dot position plus target dot transform dot up, this is where the position is actually going to be. All right, we are moving the position to the player's like waist area. All right, so now after that we are going to actually do the camera settings dot. Now we want the cam collision point. So actually the cam position, yeah, exactly. So where the cam is positioned, okay, we want the cam position. Okay, so now with the cam position, the next thing we actually going to do is to get the position of the cam. All right, dot position. All right, to get the position of the cam. Now we're going to store the results of the object we hit in our hit value, and the next thing is we have to add some layer marks. So I'm going to go to my camera settings and then add the layer marks for our raycast. So if you don't understand any of this, don't worry, I'll explain further after the code is done. So first we're going to create a public layer marks, and we say camera collision layers. So the layers the camera can actually collide with, the objects the camera can collide with. Okay, so it means that the objects that the camera doesn't really have to pass through. All right, we don't want the camera to be passing through walls and all these other objects which will be in our collision layer. All right, so it's going to actually prevent the camera from colliding with these guys. So now, with that one said and done, if we actually have a hit, okay, we are going to do this. We are going to create a vector 3, and this vector 3 is going to store our hit point, okay, where we actually hit, okay, and then now it's going to equal to a new, okay, so sorry, this is not actually going to store our hit point. Let's say it's going to be a new cam position, okay, new cam pose. Okay, this is going to be our new camera position. So the new camera position will now be a new vector 3. Now, from our raycast hit value, we can get the point, our line cast hit value, we can actually get the point where the hit occurred. Alright, so this is what we are going to do. We are going to get a hit dot point dot x. So the x value for our hit point, we are going to add that to the hit dot normal. Okay, dot x, we are going to multiply this by 0.2. Okay, a float of 0.2. We're going to do the same for our y. So we're going to say hit dot point dot y plus the hit dot normal dot y again times, so 0.2 again. So this time I'm going to set this to like 0.8 on the y. Okay, we might edit this value later on to see what best works for us. All right, so right now let's say this works for us now. Hit point dot z on the z axis plus the hit dot normal, okay, dot z times 0.2. all right, so now we have this set up for us. We're getting the new camera position. Now what we actually going to do is to move the camera to a new position. Okay, so to do that, we actually going to do a lapping function here. Okay, so we're going to access our main cam, access the transform, access the position of our main cam. We're going to set the position to be equal to a vector 3 dot lap function. We're actually lapping the camera position to a new position. So the main cam, the transform, the position is going to move from this position to the new cam position we just calculated for right here. So this new cam position, and we're going to get this new cam pose, and we are going to multiply it by, we're going to do this in time dot delta time by the camera settings and then the camera move speed. So that's how fast we always want our camera to move. So the move speed handles dot move speed. So the move speed handles how fast our camera wants to move. So that's a value we set in our camera settings serializable class here. Alright, in the camera settings class, this camera settings class, we have the move speed value here, and in this camera settings class here, it's lying here. Alright, so now we have this down. We are moving the camera when we collide with the wall. Now we want to have another check else. So now if we are not colliding with any other object, okay, we want the camera to actually, so we say the main cam to transform with local position. We want the cam to remain where it's supposed to be originally. So we say main cam to transform with local position. Now notice why we are using local position here, and I'm going to explain all these to you guys, so don't worry, it's going to make sense in a bit. So we are going to say main cam to transform with local position, comma, and then we want the initial position of the camera. So initial cam pose, and then we are going to do this in time dot delta time times camera settings, yada yada dot, and then the move speed again. So we move the camera back to its original position in some record time. So now here we're using the camera, we're using position, and here we're using local position. I'm going to explain it to you in a short while. So we have an error here. I added 2 parentheses, and I guess I have to move this guy to, yeah, we fixed the error. Now the next thing is I want to have a way to visualize our ray. Okay, so now we know the ray is traveling from this part, from the player's position plus the up vector of the player, and to the camera settings dot cam position we set. All right, so inside of this function I'm going to do debug draw line. So I want to actually visualize the ray that is being drawn so we can understand. So when I explain, you get it right. So target the transform dot position, okay, plus target the transform dot up, and Visual Studio just froze. This sucks. Alright, so okay, we're going to have camera settings dot cam position dot position, and we will set the color of the ray to be, we say color dot let's say blue. Okay, so let's show the ray as a blue color. So this is like a debuggable helper over here. So now we can save this guy. Now we need to call this function. Now remember I talked about this is being executed in edit mode. So I think we need to write a check here. We're going to say if not application dot displaying, then displaying, not displayer. All right, so dot displaying, we have to return out of this function so that this function doesn't run over and over and over again. So this code is going to handle the camera position for us. So now what we actually going to do now is call this function here. Okay, handle cam position. Right, so now we have this set up for us, and let me explain to you what this happened. Now here initially we are creating a transform to store the camera position, and we have a layer max to store the layers we can collide with, the camera can collide with. Also we're storing the initial position of the camera, and a raycast to actually store if the ray is cast and then it hits a particular surface, it's going to store those information in this hit value. That's why we have this raycast hit value. Now the next thing is, in our start function, we actually setting the initial compose to be equal to the main camera's local position. All right, the main camera's local position. That is why over here you could see we actually using the local position to send the camera. We're using the local position to send the camera back to the initial position. Right, now because the camera is actually a child, if you go to the camera is a child of this center object. We don't really need the global camera position. All right, we don't need a camera position in the world. We need a camera's position as in reference to its parent. So the local position. All right, the camera's position reference to locally within its parent. All right, that's how we need to reset the camera back to its default value. All right, so now the next thing we're going to do now is actually here what happened is we are checking if the application is playing, and if it's not playing we have to return out of this function, but we don't want to be casting rays whilst in edit mode. Now we are checking that we are creating a physics.linecast function, and we are saying it should start drawing a ray from the target's position plus transform.up of the target of the same target position. So if you look carefully, I told you if we select our player here, this is our player's position. Transform.up will be around here. So when we add the player's position to transform.app, it will be around the player's waist. So the ray will be going from the player's waist outward, all right, to the camera settings dot the cam position dot position. And the cam position in the camera settings, is a transform, which is actually going to store the cam position. Okay, this transform here, right? So now with that done, we are storing the hit value of our array, and then we are actually saying the camera to only listen to the collision on these collision layers in the camera settings variable we created up here. So in the layer max, we are actually looking for collisions on elements with only these layers. All right. Then when we get a hit, we get the hit point, the point at which the hit was occurred, and the normal of the hit. We add these two values and multiply it by 2 on the x. We do the same on the y, but we multiply it by 8 on the y, and on the z we multiply it by 2.2. And then here we actually changing the position of the camera by letting to the new position. All right, the new vector 3 position we got here. Now this position is a global position. It's a position on the world scale. Okay, on the global scene. All right, it's not a position that is local to any game object. That is why we are using the position. We are not using local position here. We actually want to move the global position of the camera to the global position, okay, the hit point in the world, which is the new compose we are actually generating over here, and we are multiplying it in time with delta time times the camera settings dot move speed. Okay, so you can see that is done. And then here if we are not actually hitting any other object, we want to move the camera's local position back to the initial position, because we took the initial position right in start. Okay, and that was the local position. So we know the initial position once we start our game, so we move back to that position. And now over here we are actually drawing a line to show our array, and you can see our array is starting from the target to transform the position plus the up vector of the target, which is the player, and exactly as it is over here. All right, and then we're doing the same thing. And the array is traveling to the final position, which is the camera position game object, and then in a record time and now we actually having a color here. Okay, we're showing a color over here to display our line. Okay, the debuggable line we're going to draw in the Unity in our game view. All right, so now I think it's done. So let's head on to Unity, and then let's select our camera. Now you can see over here we need a cam position, and now the cam collision layer. For now, let's just set the layer to default. Okay, that the camera, anytime the camera collides with any object which is a default tag as default, any layer tag as default, the camera should collide with those objects. So let's look at an example. If I select this wall over here, this cube, you can see it's tagged as the default layer. So now we are very sure that the camera can collide with this guy because the layer is set to default. All right, let's go back to our camera object. Now over here we need to set the cam position. All right, so now within our camera, I'm going to create within our center position of the camera, I'm going to right click the center position of the camera. I'm going to create an empty game object, and I'm going to name it cam position. Now this object is going to be where the cam actually is. Okay, so what we are going to do is we're going to select our main camera here, and then copy the position, copy the component, the transform component, so that we can copy the camera's position and apply it to this new game object we created, which is over here. We want it to actually be on the same position with the camera, so I pasted the values, and now here we go. Now in our camera folder, we are going to drag the cam position here, okay, which is going to store the camera position and help us track our camera so we can collide with objects. So I'm going to press play so we can test this guy. Now I'm going to enable gizmos. Okay, when I click on gizmos, all right, let's go back to the scene view. Right now with gizmo selected, you can see a blue line from our character's waist. I told you around the waist because I told you the transform dot position plus the transform dot app will give us like a position around the player's waist, and it's drawing a ray from a line cast, okay, moving from the waist to where the camera is with the help of this cam position object, because this cam position object is exactly aligned with the camera. All right, and now since we have all these set up, uh, it will handle the collision automatically for us. So let's go straight to this wall over here and let's try something. You could see we can't actually go through the wall, right? Look at what happens when we try getting through the wall. It pushes us and bounces us, right? It bounces us forward. We can't actually go through like before. And what we can do now also is, in our camera, it's kind of like showing us a bit of the wall, a little bit of the wall. So we are going to change the clipping plane, the near clipping plane. We're going to drag it down to, let's say, about 0.01, so we don't see through the wall at all. So now when I play the game, I move towards this guy here, and here we go. You see, it pushes us forward, and we can't actually see through the wall. So the camera doesn't go through walls. The wall is blocked. All right. So now we don't go through walls. Look at that. Looks good. Perfect. So now everything works cool. So now, all right. So now, like I said, we are done with this tutorial. So in the next tutorial, we'll see what we can do. All right. So I don't know what we are going to be doing, but this is getting exciting. So I think maybe we might tackle some complex stuff and see how things go. All right. So stay cool, enjoy your time, and take some breaks, and also come back, watch my tutorials, and then let's see how that goes.